So let's see what happens to a packet inside the network traffic. Please note, the data unit transferred between two endpoints has different names in each layer. In layers 5, 6, and 7, application layers, it's called data. In layer 4, transport layer, it's called segment for TCP and datagram for UDP. In layer 3, the network layer, it's called packet. In layer 2, the data link layer, the data unit is called frame. Now, I usually use packet for the transferred data unit in each layer to make it less complicated for you. Make sense? Before looking at the road trip of a DNS query in detail, let's look at the relationship between the OSI layers and computer systems. The packets in Layer 1 and Layer 2 are managed by network interfaces of your device, for example, by your Ethernet card. And the packets from 3 to 7 are managed by the processing unit. In software detail, the Layer 3 and Layer 4 packets are managed by the operating system of your devices. And the packets of Layer 5 to 7 are managed by the related application or service, for example, a web browser. When you write a URL in the address bar of your browser and hit Enter, the first thing it sends is a DNS query. A DNS query is the process of a computer or networking device making an inquiry to get an IP address for a DNS name such as mail.yahoo.com. The client computer will send a DNS query to one of their Internet Service Provider's DNS servers. The DNS server looks in its DNS database to tell whether it can answer the query authoritatively. If the DNS server can answer authoritatively, the DNS server answers the query and the DNS query process is complete. So let's see the road trip of a DNS query from your computer to a DNS server. When data is transmitted by the source toward a specific destination, it passes through the application, presentation, and session layers, and the protocol data unit arrives at the transport layer, Layer 4. Layers 5, 6, and 7 are displayed as a single layer to simplify the presentation. At this layer, a 20-byte data header is placed in front of the data. A DNS query can also use TCP, but let's assume that it uses UDP at this time. The data and the Layer 4 header, here it's UDP header, which together form a segment or datagram, is passed down to Layer 3, the network layer. The network layer places its Layer 3 header, here the IP header, in front of the received segment, and this group becomes a packet. The Layer 3 header contains important fields such as the logical address, the IP address, of both the source and the destination device. The newly formed packet is then passed down to Layer 2. The data link layer creates a new data unit called a frame by adding the Layer 2 frame header, which is the Ethernet header here. Like Layer 3, an addressing structure is also applied in the Layer 2 header. That is, the MAC address. The frame is then passed down to the physical layer, which converts the information into 0 and 1 bits that are sent over the physical media using electrical signals, on a copper link, for instance. Finally, the data is sent over the wire using a wide variety of methods such as Ethernet or token ring. The headers are a specific form of control information that allows the data to go through the network properly. Thus, the data at each layer is encapsulated in the information appropriate for the specific layer, including addressing and error checking. The overall size of the information increases as the data travels through the lower layers from Layer 4 to Layer 1. The destination device, which is the DNS server here, receives the data, and this additional information is analyzed and then is removed as the data passes through the higher layers up to the application layer, where the data is decapsulated. The physical address, commonly the MAC address, which is located in a special field in the data link layer header, changes as the packet passes from one device to another. For example, from the source PC to a switch to a router to another switch and finally to the destination PC. However, the original IP source and destination addresses do not change when transiting the network. because the packet is stripped of its Layer 3 header only when it goes beyond a router. When it stays within the same LAN, it only passes through switches which decapsulate it at the Layer 2 header containing the MAC address. As a result, the header changes as the packet is re-encapsulated, as does the MAC address fields.